Today is the second lecture on the topic geometry itself. In the first class we discussed about the different type of geometrical things or geometrical shapes. Two-dimensional geometrical shapes we discussed in detail, and then we discussed about their sum of interior angles. Then circle related theorems we learned in detail. Then area volume related things that is needed for the next chapter, mensuration. There we will discuss this in detail. And then Pythagoras theorem is needed, that also we will discuss in the distance and direction chapter. So anyway, today we are starting geometry related to counting of figures. This is an interesting and easy topic actually, and in many exams they have asked this question. That means count the number of figures. The figures may be triangle, figure may be square, figure may be parallelogram. I will be taking those questions that are more important in CSIR-NET perspectives. So this is a December 2019 CSIR-NET problem. All of you make an attempt. So I'll start explaining the number of triangles in the figure. Yeah, counting related problem they can ask in two ways. One is manual counting related questions. That means you have to manually count it. There is no other shortcut formula or technique. You have to systematically count it. Second is formula based counting questions are there. And how to decide whether it is manual counting or not? Look at the answer options. If the answer options are small, most probably you will be able to do it manually itself easily. Here the options are only 9, 10, 11, 12. So definitely you can count it yourself itself. You don't need any formula. And getting a formula here will be tough also, because it is not a what we can say perfect shape or a symmetric shape as such. If it is like this, there are formulas for that. But that was not asked in CSIR-NET. These kinds of figures have formula to find the number of triangles. That all will be asked in SSC, GATE, those kinds of exams. It is asked more. Yeah, especially in bank, SSC, those kinds of exams. So anyway, here the number of triangles you have to manually count and be systematic so that you don't miss any triangle. So one triangle, second triangle, third triangle, fourth triangle, fifth triangle. I am saying about the smallest triangles possible. 5 triangles already counted. Now more triangles you can see if you see the combination. 2 triangle together you can form a triangle here. 2 triangle together another triangle. Already we counted 5. Now 2 more, and in this direction also you can see 2 more. That means 2 plus 2 4. So 5 4, total 9 triangles already counted. Now you can do combinations like this. This is another triangle, this is another triangle. So 2 more, that means 11 triangle. After that the biggest triangle possible, that means this triangle. That is also a triangle, so that is also should be counted. 5 plus 4, 9 plus 2, 11 plus 1, 12. And now some of you may be thinking, did we miss any triangle? To confirm it, you can check the answer option. The maximum possible answer option is 12. So that makes us easy to stop the question right away, because we already counted it 12. So it cannot be more than 12. So the answer is option D, 12. This was the December 2019 CSIR-NET problem. Okay, very simple question. So here also you have to manually count it, but remember what is this? Non-square rectangles. Many questions they try to trick you like this. Rectangles, non-square rectangles, what are the difference? Or what is the significance of this term? Why they are saying non-square rectangles? We already know squares and rectangles separately. Then what is the meaning of non-square? That is because all the squares by default are rectangles. So this is also a rectangle. But in this question we want non-square rectangles. That is why we should not count this. That is what the question is meaning. Yeah, because we consider square and rectangle separately, that even if this non-square was not there, we would have ticked the same answer, but that is wrong. If non-square rectangles are not written in the question, you should count all the squares also, because squares are also rectangles. When we discussed the theory, we discussed squares are just special rectangles and rectangles are just special parallelogram. So here as the question is saying non-square rectangles, only typical rectangle, that means rectangles whose all the sides are not equal, 4 sides are not equal, that only we need. That means we can count it systematically. First one this, second this, third one this. Now first we are finishing vertical for 4 small 2 by 1 rectangles. Horizontally also you can say this is another, this is another. So totally 1, 2, 3, 4, 5, 6. 6 rectangles of 2 by 1 size we have found. 2 row 1 column or 1 row 2 column. 6 rectangles are there. Now there are more. 3 by 1 rectangles are there. This is a 3 by 1 rectangle. This is another 3 by 1 rectangle. This is another 3 by 1 rectangle. So 6 plus 3. 9 3 by 1 rectangles we already counted. So 9 3 by 1 rectangles means, sorry, total 9 rectangles already counted. Is there anything remaining? Yes. This big rectangle is also considered. That means 4 by 1 rectangle. That means one more, and that finishes it. 9 plus 1, 10 rectangles in total. Option C, 10 will be the answer. I will summarize one more time. 1, 2, 3, 4, 5, 6. 6 rectangles, that is the smallest possible rectangle. Then 7, 8, 9 and finally 10. That is option C, 10 is the answer. Here also there is no formula, there is no need of formula. You just have to manually count it. Next question. Another December 2019 CSIR-NET problem. So here quadrilaterals are given. What is quadrilateral or what all are quadrilateral we already discussed. But from this picture it is evident that square and rectangle are the possible quadrilateral. So you have to count all the squares, you have to count all the rectangles. So let's count it. First we will count the squares. Here also answer option maximum is going to 20. So that much maximum counting is not time consuming. Systematically if you count it. So 1, 2, 3, 4, 5, 6, 7. 7 small squares. That means 1 by 1 squares. 1 by 1 squares, 7 are there. Then 2 by 2 squares. 1, 2. That means squares totally are 9 in number. 9 squares we have counted. Now it is a turn of rectangle. Yeah, there is no more square for sure, because looking at that shape, maximum possible square possible is 2 by 2 size square. That we already considered. So 9 squares totally we have counted. Now rectangles you have to count. Just like the previous question, you can count the rectangles. 1, 2, 3, 4, and then the bigger one, 5. 3 by 1 rectangle, 5. So already 9 squares counted. Now 5 rectangles counted. 14 total quadrilaterals. But now you can count the same 5 horizontally also. Vertically we counted 5 means horizontally also 5 rectangles are possible. 1, 2, 3, 4 and 5. The 3 by 1 rectangle also. So 5 plus 5, 10 rectangles will be there. And squares are 9. So 9 plus 10, 19, option C will be the correct answer. 19 will be the correct answer. If so, let's go to the next question. This was asked in 2018. What is the total number of parallelograms in the given diagram? Yeah, here the parallelograms. Rhombus is also possible, parallelogram is also possible. As I told, all the rhombus are parallelogram itself. It is just a special parallelogram. But let me clarify, this is not a parallelogram. If anyone counted this as a parallelogram, that is wrong. That is a trapezium. Yesterday I have discussed in detail about trapezium. This is a trapezium. This is a trapezium. So parallelograms only you can count. So here, yeah, the main problem is to explain which all are they. It will take some time. So listen very carefully. We will be systematic. First the biggest ones. That means 3 by 1 parallelograms. 2 possibilities are there. I hope all of you are seeing. First one in this direction, second one in this direction. So 2 parallelograms are possible. So 2 counted. Then these 2, 2 by 1 like this. 2 by 1 like this means opposite direction also 2 will be there. That is the next one. That means if you count like this, this is also 2. Again showing these 2 and these 2 As I told, this is not a parallelogram. Don't get confused. That is a trapezium only. So 4 more we have counted. Yeah, remember, you should remember which we counted, which we didn't count. Next, these 3. 1 row, 2 column parallelograms. Repeating, these 3. Same way, 3 in the other direction also. Na? This, and this. These 3 and these, before that we learnt in the other direction, this, and this. So that is the 3 plus 3, 6 more parallelograms. Again showing these 3 and these 3. They are different. Don't get confused that whether they are same or not. No, they are different. One is in this direction and other set is in this direction. Both are different. So we counted 3 plus 3 more. Now these 3 diamond shape, they are also parallelogram. Parallelogram means opposite side should be parallel and equal, and opposite angle should be equal. That is satisfied here also. Again showing this one, this one, this one. These 3 parallelograms also. That means 3 more added to the list. Now there are small parallelograms, 10 in number. These are 5. Repeating, these are 5. 1, 2, 3, 4, 5. These 5 parallelograms, and in the opposite direction also 5 will be there. Same way, opposite direction 5. That means in this direction 1, 2, 3, 4, 5. That means 5 more. And finally, the 2 by 2 parallelograms possible. 2 by 2 means this one and in the other direction this one. So 2 more, and that finishes the count. Adding it up, you will get 27. So the answer is 27. Yeah, I totally agree. At the time of exam, this may be a confusing question, because if we miss one set of parallelogram, you may get a wrong answer, and that wrong answer may be there in the answer option also. If you miss these three parallelograms, you will get 24, and 24 is there in the answer option, or any other 3 set. So be very careful in this. As I told in the previous classes also, I told I will teach you all the things, but you should decide at the time of exam which question should be attempted, which question to be skipped. Because even if you have learned everything, you cannot attempt all the 20 out of 20 questions, because CSIR allows you to attempt only 15 questions. So there itself you have a choice to skip 5 questions. And I will not say that all of you should try 15 out of 15. That depends upon the time you are having. Your subject part also, your aptitude also, you should have a balance. You should decide before the exam that I will give this much time only to the aptitude section. By that much time, how much questions you are able to do fast, that is your first priority. Your first priority should not be to get 15 out of 15 questions, right? Your priority is to get maximum marks in minimum time in part A, so that your remaining time can be allotted for your subject part. So anyway, let's go to the next question. June 2013 CSIR-NET problem this is. In this question, unfortunately, manual counting won't be practical, because look at the answer option, 56, 70, 86, 100. That means in the worst case, you can count till 100 also, if 100 is the answer, because we don't know the answer, right? So definitely in this question, if you don't know the technique to do this question, it is better to skip the question, because by manual counting, chances are so high that you may get a wrong answer. So that is why I will teach you the formula or the technique by which these kinds of questions should be done. First of all, this type is, here there is 4 rows and 4 columns. That means n by n case. Row number, column number are equal. When row number, column number equal, you have a formula. When row number, column number not equal, you have another formula. So I will explain that in detail. First of all, in this question, what is asked? Rectangle which are not squares. That means non-square rectangle. That means from the full rectangles, if you subtract all the squares possible, that is the answer. Here, these are the two formulas you should remember. Number of squares in an n by n matrix or n by n system will be n into n plus 1 into 2n plus 1 by 6. Yeah, you may be thinking that this formula you have heard somewhere. Yes, this is the formula of sum of first n consecutive squares. In arithmetic, you are learning 1 square plus 2 square plus 3 square plus up to n square. For that, you have the algebraic formula n into n plus 1 into 2n plus 1 by 6. Same formula itself, because that is the same reason why you are getting this. I will explain that also, the reason also in less time. So, number of rectangles in an n by n system, n into n plus 1 by 2 the whole square. Yeah, this is the cube formula. 1 cube plus 2 cube plus 3 cube plus up to n cube. If you remember the cube formula, you don't have to learn anything more. That cube formula is for rectangles. Square formula is for squares. So, let's see how it is applicable here. Here there is n is 4 because it is 4 rows and 4 columns. So, you just have to substitute 4 instead of n. That will give you the number of rectangles. So, 4 into 4 plus 1. 4 plus 1 means 5. 4 into 5 by 2. 20 by 2, 10. 10 square, 100 will be rectangles. And the answer option 100 is there in the answer options. Just to confuse you or just to give you a wrong answer. 100 is not the answer because question is asking rectangle which are not squares. In this, by applying this formula, what you have got is the total number of rectangles. In the total number of rectangles, already all the squares are added up. But we don't want that squares. We want only typical rectangles. That is why you have to subtract the number of squares in this list. That means you have to separately find the number of squares using the square formula. N is equal to 4 here. So 4 into 4 plus 1 into 2 into 4 plus 1 by applying it in this formula. 4 into 5, 2 into 4, 8 plus 1, 9 by 6. 2 and 3, 3 and 9 cancels 3, 30 you will get. That is the number of squares. Now what is the final answer? As the question is asking rectangle which are not squares, you have to subtract these two. So 100 minus 30, 70 will be the answer. 100 rectangle minus 30 squares. So non-square rectangles or rectangle which are not squares will be 70 in number. So the final answer is 70. Option B, 70. Yeah, this question can be asked in 3 different ways. If the question is asking number of rectangles, the answer will be 100. Because rectangles include squares also. Squares are just special rectangle. If the question is asking squares, the answer will be 30. But if the question is asking rectangle which are not squares, 100 minus 30, 70 will be the answer. That is why option B, 70 is the answer. So to give you practice, I will give you one more question. Please try this question. Very simple. Here manual counting is also possible because the number of squares and rectangles are small. Let's try with manual counting also. Let's try with this formula also. Here I want all the 3 things from you. Rectangles number also I need. Square number also I need. Rectangle which are not squares also I need. So rectangle number, here there is 3 rows and 3 columns. So definitely rectangle number will be 3 into 3 plus 1, 4 by 2 the whole square, because rectangle formula is n into n plus 1 by 2 the whole square. 12 by 2 the whole square, 6 square, 36 rectangles are possible. And squares how many? N into n plus 1 into 2n plus 1 by 6. N is 3. 3 into n plus 1, 4 into 2 into n plus 1, 2 into 3, 6 plus 1, 7 by 6. 6 and 3 cancels to get 2, 2 and 4 cancels to get 2. So square number will be 14. So if the question is asking total rectangles possible, 36 is the answer. If the question is asking total squares, 14 is the answer. If the question is asking rectangle which are not squares, 36 minus 14, 36 minus 14, 22 will be the answer. Yeah, let's see whether it is manually or when you count it also, whether you are getting the same answer. Let's find the square number first, because that is the easiest. Square number 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the 1 by 1 squares. And now I will teach you how that formula comes. 1 by 1 squares are 9 in number, or I can say 3 square in number. 2 by 2 squares, if you consider the 2 by 2 square, this is one 2 by 2 square, this is another one, this is another one, this is another one. That means 4 2 by 2 squares are there. 4 can also be written as 2 square. Na? Now 3 by 3 squares, how many are possible? 3 by 3 square only 1 are possible, 1 possibility only. That means 1 or 1 square. Total number of squares is nothing but 1 square plus 2 square plus 3 square. That means if 3 rows and 3 columns are there, 1 square plus 2 square plus 3 square. 1 square plus 2 square plus 3 square means what? Sum of first 3 consecutive squares. Sum of first 3 consecutive squares, in general sum of first n consecutive squares you will do n into n plus 1 into 2n plus 1 by 6 itself. Na? And that is how this formula was derived. I just took the example of a 3 by 3 square. For 4 by 4 also this is what is happening, because 4 by 4 the 1 by 1 squares possible are 16 in number, because 4 rows and 4 columns means, if you consider vertically and horizontally, 4 into 4 means 4 square 1 by 1 squares are there. Now 2 by 2 squares, if you count it, it will be 3 square. You can check it out. 2 by 2 squares, 1 2 3, 3 in one set, 1 2 3, another set, 3 set of 3 squares, that means 3 square. Now 3 by 3 are 2 square in number, you can check it yourself, and 4 by 4 are 1 square in number. 4 by 4 means 4 rows and 4 columns, only one such square is there, na? Or 1 square. That means total number of squares is 1 square plus 2 square plus 3 square plus 4 square. 1 square plus 2 square plus 3 square plus 4 square can be easily found by the formula n into n plus 1 into 2n plus 1 by 6. That is how that formula is obtained. Rectangle formula is little time consuming to explain, so I am not trying that now. So anyway, I hope all of you understood this concept. If it is 5 by 5 system, you have to do n is equal to 5 and continue like that. That's all. So n by n case we have discussed in detail. Now what if the row number and column number are not equal? Then what to do? So that is what I am going to explain now. So I will just add one more column to this, so that there will be 4 columns and 3 rows. That means the system is 3 by 4 system. In 3 by 4 system, please don't use the formula I taught you. That only works when rows and columns are equal in number. Here it is not n by n, this is m by n system. For m by n system, number of squares and number of rectangles have a different formula or different concept. Number of squares will be done like this: m into n plus m minus 1 into n minus 1, that means reduce one number from both the number, plus m minus 2 into n minus 1 plus m minus 3 into n minus 1 till you get 0. You have to repeat this process. This is a process I am explaining. I will show you with this example itself. This is 3 row and 4 columns, that means m into n is 3 into 4 plus 3 minus 1 2, 4 minus 1 3. You have to reduce one value from 3 and also 4. 2 into 3 plus 1 into 2, because you reduce again one number from both the numbers 2 and 3, plus 0 into 1. 0 into 1 is 0, that means you obtain 0. You can stop the process there, and that value will be the answer. 3 into 4 12 plus 6 plus 2, 12 plus 6 plus 2 is 20. 20 squares will be there in this case. 20 will be the square. Now to find rectangle, that is a different formula or different shortcut. You have to apply the combination concept, because to find the rectangle you have to select a length and breadth. Length and breadth means 2 lines you need. That is a reason. Anyway, briefly I am telling the formula. M plus 1 C2 into n plus 1 C2 will be the concept to find the number of rectangles. M and n are column and row, or row and column respectively. Whichever order m and n, whichever you take first, no problem. That means in this question, m is 3 na, so you have to do 3 plus 1, 4C2 into n is 4 na, that means 4 plus 1, 4 plus 1 is 5, 5C2, that will be the answer. That will be the answer. 4C2 is 4 into 3 by 2, 4 into 3 by 2 is 6, 5C2 is 5 into 4 by 2. 5 into 4, 20 by 2, 10. So 6 into 10, 60 will be the final answer. And in this case, if 60 is the final answer for rectangle. If the question is asking rectangle which are not squares, what you have to do? You just have to do 60 minus 20, rectangle number minus square number. So I hope all of you understood squares which are not rectangles which are not squares for m by n case also, for n by n case also, and how to count rectangles and squares also. Let me give you one more practice question. What if this row is not there? Calculate it fast. If there is 2 rows and 3 columns, it is very simple. Even manual counting is possible, I agree, because the number is small. So we can do this formula, and then using manual counting you can check it. Square number, if you want, 2 into 3 plus 1 into 2 plus 0, because next value will be 0 into 1. So you can stop it there. So 6 plus 2, 8 squares will be there. Yeah, manually if you count also 1, 2, 3, 4, 5, 6, then 7, 8. 8 squares are there. Now rectangle number how many are there? 2 rows and 3 columns. So 2 plus 1 C2, 2 plus 1 means 3 C2 into 3 plus 1 C2, 4 C2. 3 C2 is what? 3. 4 C2 is what? 4 into 3 by 1 into 2, 12 by 2, 6. So 18 rectangles will be there. So rectangle number 18, square number 8. Rectangle which are not squares, if you count, that will be 18 minus 8, 10 also. That also is clear, I guess. Let me give you a little more bigger question. If there is one more set like this, 3 rows and 6 columns, find the number of squares and rectangles. Square number, you have to use the procedure that 3 into 6 plus 2 into 5 plus 1 into 4 plus 0. When you get 0, you can stop. That means rectangle number, square number will be 18 plus 10 plus 4. 18 plus 10 plus 4 is 28 plus 4, 32. So 32 squares are possible. Now how many rectangles are possible? Using m plus 1 C2 n into n plus 1 C2 concept. M is 3. 3 plus 1 is 4. 4 C2 into 6 plus 1, 7 C2. Simplify it. 4 C2, 4 into 3 by 2. 7 C2, 7 into 6 by 2. 2 cancels with 4. 7 into 6, 42 into 3. 40 into 3, 120. 42 into 3, 126 rectangles will be there. Yeah, definitely in this kind of a question you cannot manually count it easily. So you have to use this technique itself. I hope all of you understood this concept of counting using the technique of number of rectangles and squares using these two techniques.